Welcome everyone to our live streaming session about hexagonal architecture. In the previous sessions we covered some fundamentals, but now we'll be zooming deeper into layering and vertical architecture. In other words, how do we structure, for example, if we're using layered architecture, how do we structure the layers inside the hexagon? And let's see, these are also some general reading materials for anyone interested in hexagonal architecture. But now let's get onto the practical stuff. So first of all, this is a quick overview of what we did last time when we started with one MVC application, which had everything together, all the concerns like presentation, business database. It was all in controllers. We saw how we need to split between controllers and services last time, introducing repositories. And this is a typical 3-layer app. So this is what we did last time in live coding with Marcus. And we saw how to transform it with hexagonal architecture, whereby essentially our application is separate from presentation, the REST API controllers, and separate from any implementation associated with the database. So that was what we covered last time. And now we're going on to the new exciting topics, which is how do we structure stuff inside the hexagon. And this was a question that was asked by so many people, so that's why we're having this session about this today. Here is some general legend which will be used across all the subsequent drawings. So we will be talking about our application, which is the hexagon. And we'll also be talking about possible layering. Now, at this point about layering, that's actually independent of hexagonal architecture. So I just realized I'll move it down. But anyway, coming back to hexagonal architecture, we have ports. And we will also be representing implements relationship and users. So implements is when we have a concrete like class implementing an interface, whereas users is, for example, a certain class needs to use another class or another interface. So this is all the topics that's related to hexagonal architecture, whereas this, the specific choice of layering, is independent of hexagonal architecture. This is more prescribed by, onion architecture, clean architecture, etc., but not by hexagonal architecture itself. And another thing to point, even though you'll hear me talking all the time, interface, class, probably that will sound familiar to people who are from like Java, .NET world. In some other languages, interface might not exist at all, but instead abstract class. So you can think of it as abstract class. And also some people might be doing functional programming, not object-oriented programming. Even though here I'll be speaking in terms of object-oriented programming for implementation, all of these concepts you can apply regardless of whether you're working in object-oriented or functional sense. So let's get started with the simplest possible approach. The simplest possible approach to structure our hexagon is, and this is not prescribed by hexagonal architecture, so we could do anything, but the simplest one is using a transaction script. So if we had the driver ports, order service interface, and private service interface, so we had certain driver ports, and we would have implementations which implement the logic. And this would be in typically, let's say, procedural style programming. And we can see that we also have a domain but the domain is anemic, so it's just data structures. So here, basically, all the brains and heavy lifting is within the order service implementation and pricing service implementation, whereas order, customer, and product, they pretty much do nothing aside from holding data. So let's look at some pseudocode implementation, which you can later try in whatever language you have, about how this could look like. So we're focusing only on order service interface and its implementation. So we have a certain interface called, let's say, order service interface, which has methods submit order, cancel order, view order details. It has some input parameters, so some kind of request. It has some kind of response. So that's the interface. Then what would happen is we have a class. For example, we could call it order service impl class, which implements the order service. As we can see, it is implementing the submit order method, the cancel order method, and the view order details. We can also see that it has a constructor. Here in the constructor, we're passing in the order repository. So this means this implementation, if it's dependent on driven ports, those ones have to be in the constructor. Okay, here I put order repository. I missed, these ones should also be in the constructor. So maybe I'll just add them in. So order ID generator should also have been there because it's a driven port, and product repository is another dependency. And then we just store those as private variables so that we can use in our methods below. Okay. Next, as we go to the implementation, let's say submit order. Submit order would need to somehow construct the order, and submit order would do any business logic at all, including, for example, calculating the order price. So submit order does all the calculation and simply sets it, like so calls a setter or directly changes the data value of total price. This is really, really important to notice that the business logic is in the service implementation here. And the entity order, this is an anemic entity. It essentially has just some data. Okay, these could be variables with maybe getters and setters, and that's it. There is no encapsulation. This is procedural style programming. And this also happens to be something that many teams are doing. Now this, even though we can argue that this implementation is maybe not so good for abstraction, but the point is that at least this satisfies hexagonal architecture in the simplest possible way. And for someone who's just getting started out, I would say start out this way. Put all your business logic in the services, have an anemic domain model, and that's essentially the approach that is illustrated here. So this is valid from hexagonal architecture perspective. Let me see. Also, if you have any questions at any time, feel free to write in the chat. So I am periodically looking at any questions. Let's look at, also just to emphasize in terms of notation. So here, as we're reading this, order service implementation implements the interface. So it implements the primary port, but it uses the driven ports, and it uses the entities. And as you can see here, I wrote fat application anemic domain. The reason is this is fat. I mean, you can see it that I've represented it as a very big square. It's fat because basically nearly all the logic and all the code, like all the business logic, is in here. And the domain is anemic because it just has data with getters and setters and nothing else. Okay, that's the first way that we could implement hexagonal architecture using transaction script pattern inside the hexagon itself. Then, as a next step evolution, we could do the same thing, but we may consider splitting these interfaces to be more granular. So instead of having a big order service interface with these three methods, let's split it into separate use cases. Whether someone calls it use case or use case handler or request handler or command query handler. Those were also some questions from last time. So here we've split that interface into three interfaces: submit order use case interface, cancel order use case interface, get order details use case interface, and then for each use case interface we have the implementation. So this big class here, it's now split into three smaller classes. Our anemic domain model still remains anemic. And also in terms of the driven adapters, now the use case implementations are referencing only the driven adapters that specific use case needs for itself. And let's look at how this is going to be implemented. So what we would be doing is essentially having these three interfaces: submit order use case, cancel order use case, view order details use case, and they would each have the handle method. Now, I'm sure someone will see that this looks like, I mean, duplication. They all have the handle method. You could, as a side hint, have some common interface, like use case interface, which defines the handle method, so that, and then use generics so that you don't have to like retype this multiple times. But anyway, let's stick to this basic one for understanding first. So what happens is here that each use case, it can inject any driven adapters that it depends on, like this one, as well as any others that it has. And notice that we did cut and paste. So these methods are now going to be cut. So this will be cut into one handle. This will be cut into another handle method because there's three use cases. So this is our transfer of the submit method here. We cut and paste it into one class. Then in our next class, cancel order use case implementation, we have its implementation. In the view order details, similarly, also its implementation. And the anemic domain is still anemic. We did not do any changes there. So as we can see, both of these implementations are transaction script. I mean, I call it transaction script 1 and transaction script 2. So, I mean, they are both transaction script. The only difference is the granularity of these ports. Okay, let's see. Great that we have some questions. Okay, let's see. If we don't have rich domain models, will it be considered as a code smell or bad practice? Okay, I will give that answer from two perspectives. From the perspective of hexagonal architecture, hexagonal architecture itself does not care whether you have rich domain or anemic domain. I just really want to emphasize that hexagonal architecture has nothing to do with domain-driven design. So this means you can choose to have an anemic domain, you can choose a rich domain. Both of them satisfy hexagonal architecture. So hexagonal architecture considers it neither good nor bad. But it's from completely other concerns unrelated to hexagonal architecture that you can consider it good or bad. What happens is it goes back to procedural programming. What happens is here that essentially we have procedural programming and we have no way to easily enforce certain invariants in this entity. So maybe the entity could get into possibly invalid states and we won't know it. The code here becomes too chunky. And we could argue that it doesn't follow adequate separation between workflow logic versus business logic. But all of these reasons, which I said right now, it's unrelated to hexagonal architecture. To summarize, from hexagonal architecture perspective, this is valid and fine. But from your domain complexity perspective, okay, if your domain is simple, this is fine. You're not going to really have any problems. But if your domain is complex, then you're going to face maintainability problems in modeling a complex domain in a procedural way. Wouldn't in transaction script example even repository pattern be too much? Directly using an ORM directly would be a perfectly valid approach for this style. This is an excellent comment. So here I'm going to put a small disclaimer because there are two ways that transaction script could be implemented. Here we are choosing to do transaction script implementation with FinDB wrapper via interface to satisfy hexagonal architecture. But this implementation here is that we see transaction script implemented in a way to satisfy hexagonal architecture. Transaction script in the wider sense, if we were not considering hexagonal architecture at all, transaction script in general can talk directly to the ORM and DB. So that's yet another possibility, but in that case, it would simply not be hexagonal architecture. Even if we see the handle method duplicated, it helps a lot to understand the meaning of the interfaces now. So yes, exactly. That's actually the reason why in this demo, why I put it separated like this, because it is easiest for understanding. But now maybe on the side, I'll also write how I do it in reality. So I'll maybe write it, okay, here. So in reality, instead of doing this, I would have some base interface, and this could be either done by me or come from some library, but I would have some base interface, and that interface would have handle, and that interface would have some kind of generics, some request and response. And then here, so now I'm showing actually what I do in real life. So this one is for understanding, whereas this one is what I'm actually doing in real life. So I have it like this. And then I actually have no need for this at all. So I actually don't need this at all. Then I cut out that out. But when I implement it, Notice the massive reduction here. We don't need to, I'm just gonna cross this out. We've read, we now don't need this, but just doing it like this, which is way less code. And then what I do here, since these interfaces don't exist, they just go like this. So submit order request, submit order response, and then here I have the submit order request, submit order response, so I can just copy paste that. And I do the same thing below. So I make it implement that common interface, except now it's cancel order request and cancel order response, and then again copy paste this thing here, the request and the response, and I also copy paste it once more. So this is what I actually am doing in practice, and this is view order details request and view order details response. So that's my request, that's my response. So it means that, okay, I still have to do work when I'm implementing, but I've cut all the interfaces and it's replaced by this. Whoever wants to learn more about it, I recommend you command dispatch pattern, that you look at these two patterns if you want to implement it this way. Okay. And for example, if you're, a famous library in .NET is Mediator, which basically enables you to do this, and it's also been ported some similar variants to other languages. Like in Java, it's pipeliner. So this is the .NET and Java, where we can implement what I've illustrated here. Okay. Mediator, yes, provides beautiful abstractions for these patterns. Exactly that. That's right. I'll be back in just 1 second. Okay. In Go, for example, I even use functions in order to define my use case. So this is a really good point, that we actually don't need these classes. So here, instead of these classes, it would have been perfectly acceptable that we had functions instead and not classes. So that would be the functional variant of doing this. Okay, what is a fat application? Maybe here I could be more precise in terms of naming and call it the fat application layer. Yeah, that would be a better name. And anemic domain layer. So it's referring to layering. Now, the choice of these layers, this is independent of hexagonal architecture. So hexagonal architecture doesn't prescribe which layers we're going to have, but these are just some examples of how we can do layering. And here, fat means it contains a lot of code. So we can see that here the use cases contain a lot of code and the logic. Here the services contain a lot of the code and the logic, whereas the domain doesn't pretty much contain much at all. So let's see what's next. Yes, no need of hexagonal architecture for transaction script. You can use ORM directly. So yes, since that topic has been brought up multiple times, I will do a heading above here that all of this that is shown below is the variance with hexagonal architecture. And let me see, but we could also have possibilities of where there's no hexagonal architecture. So I'll call it the non-hexagonal architecture. That is using transaction script in its original sense, which is with ORM or SQL. So yeah, that is also a possibility. Yeah, FAT is a place with many behaviors. That's a good clarification. So it's about where are we placing the behaviors? Are we placing the behaviors in the application layer or the main layer? Here we are placing it in the application layer. So I believe it's referring to the application transaction scripting in example being FAT with business logic, but model being anemic in that regard. That's exactly right. And since multiple people have, I guess, brought up this topic, I will make a note here just to say, so FAT application layer means it contains all the application / business logic. That's the meaning of FAT application layer. Whereas the anemic domain model means anemic. Okay, I guess the more typical way that people call it is anemic domain model means entities are just data structures with getters and setters, no behavior. Sorry, this is the anemic domain model. Okay, let's see next one. FAT use case and anemic model for opposition with slim use case with rich model. That is the case that we will reach below with clean architecture. So nice that you're already writing something ahead. If we're using messages as API, okay, this one's a bit more interesting and challenging. If we're using messages as API sent from driver left adapters plus handlers receiving the messages inside the hexagon, do we still need to have interfaces as ports and implementation inside the hexagon? Okay, let me just try to address this. So first of all, the topic of whether we're using messages, so I assume you're talking about here in terms of the driver side, the topic of are we going to have a REST API or are we going to have message consumers, that in general is independent of the choice. Are we going to have REST API controllers or message consumers should not impact the choice of whether we're going to, of what design we're going to have. So that's addressing the first part. The more general topic, which has been brought up many times, and I think even in the previous session, is the question of, do we really need like interfaces at all? You know, can we just expose the implementation? The issue with that is that when we want to test the driver adapters in isolation with integration testing, that if we don't have interfaces here, we can't do proper mocking. So to summarize, what you're suggesting here, this could work. I mean, if you decide to not have interfaces, but then you would face challenges if you want to do integration testing for the messaging API. I'm not sure if my response here was clear or not. Feel free to write any follow-up in case I wasn't clear. Interface for left port is not mandatory in Hexagonal, but it is in clean architecture. Okay. I guess we could distinguish between interface as a concept versus interface the way it is in programming languages. So hexagonal architecture itself only sees ports in general in terms of interface as a concept, but not in terms of interface in implementation. So there's languages which don't have, for example, interface in the programming language at all. So we can say that only the concept is mandatory, but the implementation of interface within a programming language is not necessarily mandatory. But having interfaces, I would say that the usefulness is not perhaps from perspective of hexagonal architecture per se, the fact that, let's say, in Java or .NET that we'll have interfaces, we could go without them, but then we would face problems in integration testing for the driver adapters. Okay, you're welcome. I still remember the time when skinny controller, fat model approach was a huge discovery for me. Well, actually, I would say for many people, this would be a discovery. The reason is currently, since most teams are doing procedural style, which means fat application layer and anemic domain model. Okay, that would actually defeat the purpose of having the hexagonal architecture in the first place. So this is, again, I think, going back to this topic, do we need interfaces? I would like to just point out the difference in terms of importance of these interfaces on the left-hand side versus which are the driver ports versus the driven ports. The driven ports are the ones which are, I mean, mandatory that we must have some kind of interface concept there, because that's the only way that we can achieve separation from real infrastructure. Otherwise, if we didn't have this in some kind of way, we would be coupled to I/O, and then the application cannot be run and tested and independently of I/O. So these ones, for example, are absolutely crucial that we have something here, whether it's interfaces in the programming language itself or whatever other dynamic way of having interfaces. Whereas these ones, I would say that it is needed from perspective of being able to do integration testing for adapters, but also protecting our application. Because what happens is, if we don't have these interfaces, and if we expose these implementations directly here, but then the caller would be able to have reference to this and reference to like all the other maybe dependency injection that this has. So the presentation would then have knowledge of this plus any additional internals within the hexagon. And then we would sort of be leaking out the hexagon if we don't have these interfaces here. Okay, great. Let's say moving on. So this was an excellent discussion about transaction script. The next place where we are moving on is we're going to have thin or slim application layer and rich domain model. This is what you're going to see in Onion architecture, and also if you read the domain-driven design book, it will sort of approximately look in this way. What happens is we have these service interfaces. These are called application services. So this is the interface and this is its implementation. We still have the same driven ports, so notice that there's no changes in the ports, but the difference is that these application services are now essentially slimmer, thinner, and this domain model became bigger. So you can look at the size. Look here, it's small. And here it became bigger. So this is a rich domain model. It means we've moved behavior out of here into the domain model. And let's look at an example of how that would look like. See here that submit order in the application service, it does not know the details of how to do the calculation, but rather delegates to the order to, let's say, calculate or update or whatever else the total price. So this means that here business logic would be inside the entities. So this now is less code, and the entities now have more code. The entities are now doing business logic, whereas application or workflow logic is the only thing that remains here. And that is essentially what is Onion architecture. I read that we don't have to put infra, lib, or any external layer inside the main layer. Okay. In terms of infrastructure belongs, outside of the Hexagon. So things like databases, files, network calls, all of that infrastructure belongs like outside of the Hexagon itself. Now, the point about library, okay, that's a bit more controversial. So there are some people who have the interpretation that absolutely no libraries should be here at all, but that we have to do an interface for every single library that exists. And I must admit, even I myself was doing that for a while years ago, and it didn't work out too well. So that's one perspective. Or the other perspective is that we can reference libraries inside the use cases, inside the domain, as long as that library does not inhibit unit testability. And that's the current approach which I use, which means if that library does not prevent me from running fast in-memory tests, I feel free to use it. Examples are, I might use a maths library to calculate distance between these 2 points, and I'm not going to make an interface for it. Instead, I'm going to directly use that library here. Another library is also guard clauses. For example, I want to ensure that my entity does not get null values for something or do other guard clauses. So I also use guard clause libraries directly in here. Or any external layer. Okay, the word external, I assume you're talking about infrastructure. Correct. Infrastructure is not inside the domain. It is completely outside of the Hexagon itself. Make the orange boxes smaller. Okay. I will make it even more smaller. So let's see. Yeah, that's a good, nice suggestion. Now it's, I guess, and I'll make these ones even more bigger, just for bigger visual emphasis. Except, I have issues a bit with the drawing space. Okay, I think that maybe this is now better reflecting what we're trying to say, thin application layer and rich domain model, so thanks for that. But sometimes there are some exceptions. Do you know them? maybe you could clarify if this was in regards to anything previously said. So just to summarize, I said once again, any IO, I put it outside. But for libraries, if I can do still unit testing, I use the library directly in here. If the library prevents me from doing unit testing, then I use it only outside. But feel free to add any follow-up questions. How do we test aggression queries, or I mean, probably aggregation queries in Hexagon? Aggregate functions should be handled in business logic. How? Because in tests, we have not idea about implementation. Here, I'm not sure, are you referring to aggregates, like aggregates in terms of domain entities, or are you referring to aggregation functions in SQL? Maybe you could clarify, or I'll just give a short response. So if we're talking about aggregate routes, so for example, order might be an aggregate route, customer might be an aggregate route, product might be an aggregate route. If we're writing tests, if we have this kind of structure and we have sociable unit tests targeting the, okay, I'll change this to black, targeting the use cases, targeting, well, sorry, these application services, then this is how our test would look like. Order service test. I mean, it would be obviously a unit test. And that is correct. This would be independent of our decision to have these aggregate routes. It wouldn't have knowledge of how we're splitting the behavior. So this is the sociable, let me see. This is if we are doing sociable unit tests targeting application services. That is the current approach that I'm doing, but there is one more approach. So I think I might draw this maybe on here, since I think it is relevant to look at how we're doing testing. These are sociable unit tests. Someone could also have other approaches regarding testing, and maybe you're going to see it on LinkedIn or other places, that we could write. Now, let me just check something. In the actual test, okay, we will construct the actual order service implementation, but anyway, through the test methods, we are just calling it through the interface. But we could have like this order test targeting inside the hexagon. Now our tests have become coupled to the internals of the hexagon. And I know that now it's starting to get harder to read this diagram. But the question is, what's the impact? Here, our tests now become dependent on how we're doing this splitting. And as soon as we move behavior, let's say we do refactoring and move behavior from use case to the domain entity, then we have to update 2 unit tests. We have to update the application service test, and we have to update the domain entity test. In the past, there was a time when I was doing this, but then essentially realized, hey, we have fragile tests. So the current approach that I'm doing is this one, with sociable unit tests targeting the application services. But you'll also find a number of people doing this approach, that they are having tests targeting the domain entities and targeting the application services and updating the tests when they shift behavior. How can we ensure that the thin application layer doesn't become too thin and leads to violation of separation of concerns principle in hexagonal architecture? So the separation of concerns in terms of hexagonal architecture is only in terms of separating the application, which contains the business logic, separating it from external I/O concerns. That is satisfied in all of this. It's satisfied here, we are separating the application from I/O. Our decision of how we're going to do this layering inside has no impact on the separation of concerns between business logic and I/O. But instead, it only affects whether we are going to be doing modeling in a domain-driven design, like rich domain sense, or we're going to be doing it more in transaction script, more procedural sense. But hexagonal architecture does not care about that. So if your domain logic required, you can base it on a specific lib, but be aware of the implication. Okay, so I see that there's still that discussion. Feel free if anyone wants to add further clarifications there. What does sociable mean? So this was about the unit tests. Whoever wants to research more, you can look at unit tests. There exists sociable unit tests, and there exists solitary unit tests. I'm here going to give like a 1 minute overview, and feel free to read more. In essence, in sociable unit test means when our test is targeting a class, the class will be constructed with real instances of its dependencies, and we use test doubles only for dependencies that touch I/O. So it's saying we mainly use real dependencies, and we use test doubles only for dependencies that touch I/O. But in this case, is when our test is targeting a class, we replace all of the class's dependencies with test doubles, specifically mocks. And there's a nice, there's an article from Martin Fowler, sociable versus solitary unit tests. I'm just going to copy paste it here. Okay, it's this link. So feel free to read up on it. This topic, I want to say, is independent of to hexagonal architecture. In hexagonal architecture, we could choose either way how we do the unit testing. Okay, SQL aggregations. So this topic is, my understanding, it's talking about infrastructure. Is this the case where, let's say, you want to produce maybe a report about orders, perhaps, for example, saying, what were maybe the top orders for the month, or what's our total revenue and things like that. So certain aggregations. I assume that's what the question is asking about. In that case, we would take that into account when we're modeling our repository interface. So this means if we need to do an aggregation, such as what was the total revenue for the month, we don't want to load up thousands of orders into memory and do a sum to get the total revenue. Instead, in our repository interface, we could have a method get total order value for a month, and then we would implement the SQL the aggregation on the SQL side. Okay, so that was the thing. I think it's a hard question when we don't have to implement when we don't have to implement Hexagonal architecture, or it's a silver bullet. Okay, so I mean the standard answer is there aren't any silver bullets, but let's look at when and why to implement. If we have a startup and maybe they have very simple logic, so the logic is very simple and it can be done by just a simple CRUD application, then just doing transaction script with no Hexagonal architecture itself could do the job, and the team might have no unit tests, have only integration tests, and maybe that could be fine for a few months, for several months, for a year, depends. But as the application grows more and more complex in terms of business complexity, then, and we have no unit tests for the business logic, then it simply becomes we introduce more bugs, the tests take too long. So then, motivated by unit testing, business logic, we'd like to make our architecture unit testable in order to be able to unit test the growingly complex business logic. And that's at least for me, a big motivation behind Hexagonal architecture. To summarize, teams will see impact of Hexagonal architecture as business complexity increases. That's when the value of this architecture increases. Another question related to this is, should we implement Hexagonal architecture at the start, or should we firstly do a typical transaction script and then later switch to Hexagonal architecture? I think for many teams, that's actually what they do. Start off with transaction script, let the application grow and grow and grow. Then they get huge problems, and then they may discover Hexagonal architecture and switch over to it. But then that can cause management challenges, approvals, and other stuff. My personal opinion is I actually start with Hexagonal architecture right away for enterprise companies, but it's for enterprise companies which already have, I should say, customers, money, etc. And simply because I can predict that it's going to grow in complexity, since as far as I know, any or all enterprise applications have grown in complexity. But I do agree, it is a question with no definite answer. Is it possible to have the presentation support in PDF at the end of the presentation, please? So I will have the link to the Miro board accessible via the description or comment, so you'll be able to navigate the Miro board. The reason is it's huge, so that's why it's not a PDF. So yes, yeah, there is no silver bullet. What is the problem if we started with Hexagon, or even in a new startup, it's easy to implement? I like this response. For people who are already familiar with Hexagonal architecture, it's so natural and so easy that we can start with it immediately. And even in terms of code base, the only addition in terms of code size that one will have with Hexagonal architecture compared to just plain transaction script with ORM is we're going to have additional interfaces and we will have additional mapping for infrastructure, but that is nothing compared to business complexity. So this is another point. If a team is already familiar with Hexagonal architecture and TDD, then they will start with it in a new startup. But if a team is not familiar with it, then they will not start with it. And one example, I mean, is Mikel Azarad, who, for example, when he wrote about developing for startups and stuff, also starting with Hexagon, Clean, and TDD. Okay, so let's continue on. So we covered the onion architecture, and we also have the clean architecture. Clean architecture is just like onion architecture, and it has these characteristics as well. The only difference is that clean architecture does not have application services, but instead it has these use cases. So instead of having this application service with these methods, instead we split it into use cases. And once again, you can use the command dispatcher pattern here to avoid, I mean, having so many interfaces, but everything else is essentially the same. And last of all, I want to get to vertical architecture. So in vertical or slice architecture, I mean, everything above it is referred to as horizontal architecture because we have that strict separation of I/O from business logic. But in vertical architecture, which is another architecture category, it is different. In here, it's per request that we make decisions. So we may decide for submit order use case that due to the domain business logic complexity that here we want to do, domain driven design. So that means having rich entities, having all of these interfaces, and do it like this for the submit order use case. But maybe for cancel order, maybe there's not really any business logic. Maybe it is all just about setting one status field to be canceled. And perhaps here we make a decision to make a direct call to the ORM. And on this request handler, we may decide to use raw SQL or call stored procedures directly. So no interfaces, no abstraction. And for another use case, we may decide to do some hybrid. We might be coupled to, let's say, a HTTP client and call it directly. But perhaps for our repository interfaces, we don't want to do a direct SQL call, but rather do it through a repository interface. And so here, most of code, it is split in these so-called vertical slices. There might be some shared code. For example, here, both this and this needed product and its repository, but generally this is kept minimized in vertical architecture. The difference between hexagonal architecture and everything we did above versus vertical architecture is the separation of concerns between business logic and I/O. In hexagonal architecture, we ensure that separation exists. In here, so in hexagonal architecture, that decision is made for the whole hexagon, that we will have that separation between business logic and I/O. Here, it is on a case-by-case basis per request handler that we are deciding to split or not split business logic from I/O. So here, we split the business logic from the I/O. Here, the business logic and I/O in both of these ones is coupled. We are directly coupled to the ORM, directly coupled to SQL or stored procedures. So if you want to find out more about vertical slice, that's Jimmy Bogart. And let's look at the impact on unit testability. So in all the variants above which satisfy hexagonal architecture, we can fully unit test the application. So the whole application is unit testable. Here, some requests handlers may be unit testable, like this one. Others are not unit testable or partially unit testable. In practice, I mean, I'm currently using hexagonal architecture, more specifically the clean architecture derivative of it. This is what I use in practice, but even on new projects. But all of these other ones are shown so that you get essentially the full spectrum of knowledge. Let's see. Okay, there's several more questions. Do you prefer starting with a single module and rely on separating by packages, or separate in different modules from the start? Gradle Maven. Okay, I like that question. It's practical and implementation. So let's see. Here, let's say we are making a monolith first. So we have a monolith, and let's see how we will split. In Java, it's called, let's say, Java Gradle Maven modules. In .NET, it's called projects. All of these are essentially separate physical packaging. The minimal which I currently use is as follows. So I'll show you both the minimal as well as the not so minimal. But as the minimal, you need to have the hexagon, whether you call it hexagon or core. It's the representing the yellow stuff in the previous diagrams. But we also have, aside from yellow, we need to have some driver adapters here. So I'll put that in, let's say, this gray. Driver adapters. And we also have driven adapters, which I discussed in previous YouTube sessions. We need this, and this is the minimum. Hexagon core. Well, you could group both the adapters together. This is the barest minimum. And then when you have your unit tests, this is the stuff where you're going to have unit tests associated. Well, I can draw now, I guess, the relationships between what depends on what. So hexagon, it's nothing depends on it. This is crucial. Adapters depend on the hexagon. Unit tests depend on the hexagon. And we also have integration tests, which depend on the hexagon. This is the minimum. Then, if we, oh, and by the way, a hexagon thing, this contains the core plus the ports. So the ports are here. This is the minimum structure that I can think of. Then when we go beyond the minimum, we can say that we're going to split, let's say, into driver adapters and driven adapters. That's the next level splitting. So our driven Okay. And we could do even further splitting by the different adapter. So we could have a REST API is one of the driver adapters. Another one is RabbitMQ message, RabbitMQ consumer is also another driver adapter. And in terms of the driven adapters, this is where we would have, for example, Postgres persistence adapter. Then we could have MongoDB persistence adapter. Now you've noticed that Hexagon core, I did not continue splitting it at all. This is currently, this works if we essentially have a single domain, or like a single bounded context, like this. We have just, one Hexagon core, which is modeling that single domain, and we have these adapters, and that's it. And I would say for many projects, this will work, and this kind of setup is probably the one that's most corresponding to what I'm currently doing with teams in practice. But you could ask a question: what if? Oh, and of course, now these here are the physical, modules and projects. Inside, you can have namespaces. So, sorry, in Java. So now I'm going to get to what's inside. So the topic of in Java packages or .NET namespaces. So what could they be? I typically have at least minimum something like internal or impl. This is where I have implementation of application services or use case handlers. And I also have one for ports. We could split between driver ports and driven ports. In terms of naming, whether you call it driver ports, it could be essentially like this. So you have the implementation and you have the ports. And this is a monolith. The problem is, what if your domain starts getting more and more complex and you don't want this to be one Maven module, but you want to split it further? In that case, maybe we could cover it in a future session. What we do with monolith versus modular monolith, which would actually involve splitting this modular monolith versus microservices. I'll see based on time when we'll be able to do that, but I'll now go through the other questions. How to store shared DTOs files physically in vertical slice architecture. So I'll just put here just that we have the abbreviation as well. So how to store shared DTO files. That's yet another discussion, which is for each request handler, what we're going to have is, let's say we have the submit order use case handler. or you call it just submit order handler. It will have submit order request, which is a DTO, and we're going to have a submit order response, which is a DTO. In vertical slice architecture, all of these ones need to be different. Should be different per request, so that then you can use the command dispatcher pattern. So these ones should be different DTO classes. Even if the data is inside the same, you need different physical classes. That way the command dispatcher will be able to dispatch to the right use case. If you don't have it separate, you cannot use the command dispatcher pattern, and then you'll have to manually disambiguate, which I don't recommend. And there's that also other point about shared DTOs in general, and because it's a topic of controversy. So when our application is really simple initially, we might think, hey, you know, why would we have separate DTO files when, like, you know, create order request and update order request, they look the same or almost the same. That's the case when the project firstly starts out. But then as it evolves, what happens is these requests naturally become more and more different. And if we start modeling it separately from straight away, we will find it easier. Our change is localized to the request handler. But if we had shared, we would actually reach problems later on. If we implement Hexagon or Onion or clean architecture, does it impact team organization like microservices? Okay, so microservices, they impact the team organization in terms of a team will work on one microservice and to avoid multiple teams working on one microservice. But in terms of whether we're going to choose hexagonal or not to choose it, that's a decision within a microservice. It does not affect team organization in that sense, because a team member, they should be able to work on the use case and the entities and the infrastructure. So no splitting there. A hexagonal and vertical architecture are not opposite. Hexagon is a subset of vertical. No. Okay, I like this question. If you read the material of Jimmy Bogart, and here is the website where he has vertical slice architecture, and if you read it, you will find that Jimmy Bogart does not like hexagonal, onion, clean. He made vertical architecture in response to having a bad time with hexagonal and clean. And in fact, in some other articles, he also writes, for example, smelly onions, which refers to, it's essentially putting down, you know, onion architecture and the similar. So he like layered architecture at all, and developed this in response as an alternative to layered architecture, because in layered architecture, we are forced to separate I/O globally across the whole application. Here, he wants to make a choice for himself, that he can choose in some requests to separate I/O and business logic, and in some to not separate. So if we look at vertical architecture from the perspective of Jimmy Bogart, who came up with it, they are two separate things. So he developed vertical because he doesn't like hexagonal. But if we ignore Jimmy Bogart and just more conceptually look at this, we could say that if you implement vertical slice architecture and do this everywhere like this, then you're basically doing clean architecture. which satisfies hexagonal architecture, if all your requests are like this. Okay, so I think that was similar to the above. I think vertical slicing can make more sense if you can speculate you will need to go to a microservice architecture because that's the highest cohesion possible. Okay, I will make, I guess, a short comment here, and maybe we could put that as a to-do for the future. Feature splitting and path to microservices, because you can actually achieve it in both. In vertical slice architecture, I guess it's quite obvious. I mean, he's already splitting it by these request handlers so that it's already partitioned by features rather than layers. But in the above, in the case of hexagonal architecture and whichever of these derivatives we choose, for example, let's look at clean architecture. Here, I'm also partitioning it by use cases, just like in vertical architecture. The only difference is I have abstraction towards I/O everywhere here. Now, if I do this splitting and I do my domain modeling well, that already itself causes cohesion. Here, if I start with this and identify proper bounded contexts, and then have a hexagonal architecture per bounded context, which is which is a topic, for example, that Michael Azerad wrote in one of his comments, but I didn't get a chance to discuss it yet, but maybe in the next session. Then you have a modular monolith, and then each such module in the modular monolith, you can migrate easily to microservices. But I think I'll leave that maybe to a subsequent next session. Alistair Cockburn doesn't want you to put left and right adapters in the same package directory. That's why there is 2 hexagons in his schema. Okay, in terms of Alistair Cockburn himself, the only thing that he defined was, he didn't even define this. I mean, I'll just say what he defined. This is just hexagonal architecture in the it's a question mark what's in here. So let me just put a big question mark. First of all, I'll just say that none of that was defined. This is also not defined by him. Now, he did in his diagram draw the adapters and the fact that the adapters were calling the prior ports, and that these adapters were implementing this was the only thing that he defined when he explained hexagonal architecture. This separation must exist. In terms of implementation, he didn't go too far in terms of giving us specific constraints. Now, I guess I could say that this first one, that probably no one is doing this. Okay, this is too big. Whereas this thing, having that separation is what would be more natural, and having this separation. If we don't use hexagonal in some vertical slices, doesn't that make testing them hard? And if we want to make these slices testable, we have to refactor to hexagonal. Exactly. So that's really well said. Here, only this request handler is unit testable. These ones are not unit testable. So we get localized unit testability, whereby in Hexagonal architecture, we have global unit testability. So that is right. If you want it to be unit testable, you then have to refactor to hexagonal. And if we want to make all slices testable, we need to make them all hexagons. So then it's better to just use one hexagonal architecture for the app. Correct. So the only difference between vertical versus hexagonal is that in hexagonal, we have global separation of business logic from I/O, whereas in vertical slice, it was localized separation. But if you want to do that separation on all the requests, well, then you end up with hexagonal architecture. So if we want to make all slices testable, yeah, exactly. This was the previous question. Okay, great. And just to summarize the final summary where we see all of this together, all of these different approaches. This is the first time that I'm doing this model in a diagram, but this compares everything that we talked about today. So in terms of all of this satisfies hexagonal architecture. So one choice that we have is how do we implement the hexagon, so that yellow part. We could have procedural services with an anemic domain, or we could have services with a rich domain. Similarly, in terms of user port, driver port granularity, we could have application services, which are coarse-grained, and we could have these use case handlers, which are fine-grained. If we have procedural services and anemic domain, we are essentially applying the transaction script with that disclaimer that we are using interface for repository rather than ORM, but it's essentially transaction script in essence. Whereas here, if we have application services and rich domain with application services, that is essentially what is onion architecture. But if we have these rich domain and we have use case handlers, then we end up with clean architecture. So this summarizes everything that we had talked about today, going through those four combinations, and all of this is hexagonal architecture. Vertical architecture is another spectrum, that's why it's not here, but you can think about essentially both of them. So thanks again, everyone. I really enjoyed all the questions that you asked today, so it was a really great discussion. I will be adding the Miro links to the YouTube video, and feel free to add any additional questions that come up on the YouTube video itself, as I will be taking into account what you write for any of our future sessions. So I want to say thanks again, everyone, and I wish you a great day. So see you next time. Thank you. Bye.